Okay, so in this video we're going to learn how to do a shortcut for electron configurations, because so far we've learned how to do it using the diagonal method, which is really handy for elements that have smaller atomic numbers. But for elements that have larger atomic numbers, like nickel with 28 or even gold with 79, using the diagonal method can take forever and can be really cumbersome and time consuming. But we can organize our periodic table just a little bit and add some kind of codes and shortcuts that'll really help us speed up writing these electron configurations. So before we can do this shortcut, we have to make some edits to our periodic table. So the first thing we're going to do is we're actually going to cross out helium, and we're going to move helium over here. Okay, so just to kind of put it over in the same group as hydrogen. Now we're going to box off some of these groups. So we're going to box off first these first two columns, first two families, and this is going to be our S block. Then we're going to block off our transition metals, and this is going to be our D block. Then we're going to block all of these elements, and this is going to be our P block. And then finally, this block down here is going to be our F block. And as you might have noticed, S, D, P, and F are our sublevels. So what this tells us is that it tells us what the final electrons, what sublevel they're going to be located in for each element. So for example, carbon, its last electrons are going to be located in a P sublevel. For calcium, its last electrons are going to be in an S sublevel. So there's one final thing that we have to do to be able to use this method. So we're going to number the very first element that appears in each, or that occurs in each block, going from left to right. So hydrogen is the first element in our S block. And then we move over to our P block, because in going in order of sublevels, it goes S, P, D, and then F. So in our P block, boron is the very first element that we come to in our P block. So that's going to get the number 2. And then for 3, so 1 is S, 2 is P, 3 is going to be D. So the first element in our D block is scandium. And we're going to put the 3 right between calcium and scandium. And then in our F block, we're going to put a 4 next to lanthanum. Although for yours it might be cerium, depending on what periodic table you're working with. But don't worry too much about the F block, because we're not going to use that a ton. Okay, so now I'm going to number down from each of mine. I'm just going to use a different color so we can kind of differentiate. I'm going to number downwards from my main numbers. Okay, so I'm going to go 1, 2, 3, 4, 5, 6, and 7. And then I have a 3 here, so this will be 4, 5, and 6. I have a 4 here down an F, so that's going to be 5. My 2 is going to be 3, 4, 5, and 6. Now, how we use this. Let's change my color one more time. Now, how we use this. So let's say I wanted to find the electron configuration of oxygen. So I'm going to start with energy level 1. So all of these numbers along the sides are going to represent energy levels. Then of course we said the letters represent sublevels. And then each individual element is going to represent an electron. So I'm going to start at 1s, and I'm going to draw an arrow going from left to right. And so since I went across row 1, that's going to be energy level 1. And I went across the S block, so that's going to be sublevel S. and I went across 2 elements. So that's going to be 2 electrons. And now I'm going to keep moving left to right until I get to my desired element. So I'm going to start in row 2. I'm going to go across, and since I went across row 2, that's energy level 2, and since I went across the S block, that's sublevel S, and I went through 2 elements, so that is 2 electrons. And now I keep going to the right until I get to oxygen. So since I went, now I'm still in row 2, but now I've entered the P block, so I'm in sublevel P, and I went across 1, 2, 3, 4 elements, so it's 2p4. So my electron configuration for oxygen is 1s2, 2s2, 2p4. Okay, so that's how I can use the periodic table to shorten my electron configuration. So now let's do another example. So let's take this and minimize it. And let's pull in an already pre-made periodic table. So let's look at let's do chlorine. So for chlorine, I'm going to start over here. So it's going to be 1s2. I go through here, 2s2, continue going left to right. Now I go through here, and that was 2p, and I went all the way across, so 1, 2, 3, 4, 5, 6, 2p6, which is what we'd expect because p has 3 orbitals, each of which can hold 2 electrons. So if I filled my 2p sublevel, then I would have 6 electrons in that sublevel. Now I keep going to 3s2, and then to 3p, not 3d, 3p, 1, 2, 3, 4, 5, 3p, 5. Okay, so that's how we can do the electron configuration for chlorine. But let's do one more example that gets a D sublevel in there. All right, so for this one, let's do arsenic. So same as I've been doing, 1s2, 2s2, 2p6, 3s2, 3p6. Now here I went through 4s2, and now through D, 3d10, if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but then I keep going to get to arsenic, 4p, 1, 2, 3, 4p3. Okay, so then I went through, so you can see how it goes when you go through the D block. And that's it. By this point, you should be an expert on using the periodic table as a shortcut for writing your electron configurations.